food dyes,
salting out, and chemical separations. What we have here is about 31 milliliters of acetone, which you might know of as fingernail polish remover, and I've created a saturated solution of rock salt and water. And so to the 30 milliliters or so of acetone, I'm adding 1 drop of this purple food dye. And the question to the audience would be, what color is that? And then to that solution, I'm going to add an equivalent amount of the saturated rock salt solution. Interesting phenomenon there would be you get a lot of solid forming because the rock salt's far less soluble in the acetone than the water. And with the stopper on, we can agitate to see what's going to happen when we mix. So now the mixture has been mixed, and has it made a solution? No. So we can tell it's not a solution because it's non-uniform. The visually interesting thing would be this purple dye is actually made of 2 dyes, a blue dye and a red dye. What we see here is that the red dye is more soluble in this upper layer, which is acetone, and this lower layer is the aqueous phase. It's hard to see, but there's more blue dye in that layer. We're now going to take a little bit of water and by adding little bits of water, my hope is that we can dissolve the salt while still having the dye being partitioned between the upper acetone or organic layer and the lower aqueous. If we add so much water, the whole mixture will dissolve into a solution. So I'm just going to keep adding little bits of water at a time, agitating until it becomes transparent. And there we have it. So predominantly the red dye component of the purple has now migrated more to the upper layer, and the blue dye is more in the bottom layer, but there probably is some red dye in the aqueous phase as well.